No, you can go.
Okay.
At least, are you ready, Ann?
Yeah. Okay, so we're the Pollinators. I'm Kayla.
Austin.
Emma.
And I'm Javert.
I'm Isaac.
All right, so background information is relatively straightforward, actually. First, pollination, fertilization. We all kind of learned this in high school, honestly. Just an insect will go to forage for nectar and will, along the way, sort of pick up pollen from the flowers that they land on. And so then they'll go off, and when they visit other flowers, then they'll end up like pollinating them just by rubbing all over them. It's sort of just a case of you scratch my back, I scratch yours, mutualism and all that. Though it's not entirely willing, so it's kind of a trade-off in that they get the nectar, but they don't want to be carrying very much pollen usually, because then they'll be heavier, it'll be harder to get around, harder to get to food. They don't really directly gain anything from the pollination on an individual basis. So the idea that led to so the idea that led to was is there a willingness to that? Like, are they going to at all adapt to kind of avoid that? And also, like, what actually are examples of pollinators? Most previous research always looks at bees, or maybe they'll look at butterflies or moths and how they contribute, but they never really compare quite. They never really compared much to each other. What I mean is that what we did is we compared how moths and butterflies compared in this sense. In the past, other studies have looked at moths, they've looked at butterflies, but when you get down to comparison, it's always been to these rather than these two parties together. So there hasn't really been much past research, which is part of why we did this in the first place. So the question basically was, does leg length affect the pollen load? Because the longer your legs are, the kind of further away your the main body is from the pollen itself. So they're going to be less directly working against it, picking up less of it. The hypothesis was that butterflies, as they sort of stand up higher, you think it looks like they sort of stand up higher, so it looks like they got longer legs. So the idea was that they would have smaller pollen loads than moths, which are kind of more loaded flower. They'll even get deeper into the flower because they have a shorter proboscis, that's the one. So they'll like have to get right into the flower. So that was the idea behind it. And then we would also, so we thought that a leg length would negatively correlate with pollen load.
So our method, we caught the butterflies and moths at William Jewell. We put them in kill jars with ethyl acetate and then put them in the freezer to store them, keep mold from growing between catching them and measuring them. So we measured the leg length and thorax. So you can see we measured the rear femur, which is circled, and then the thorax. After the measurements, they were put into conicals with 50% ethanol and vortex for 1 minute. So the vortexing shakes off all the pollen. So after vortexing, the butterflies and moths were taken in their parts that were floating around. Were taken out of the conical, put back into the kill jars. And that ethanol pollen mixture was weighed to ensure the same weight for centrifuging, because if the centrifuge is off balance, then it doesn't work. So we centrifuged the conicals 6 at a time for 30 minutes at 6,000 RPMs. After centrifuging, the pollen all sinks down to the bottom, so it's easier to collect. So we took out the pollen from the bottom of the conical using a micropipette and put them into petri dishes, which you can see over there. They're all individually labeled. And those petri dishes were placed under the microscope at 100 times magnification and counted with a manual counter. So the picture below is a picture I found on a blog spot online. We didn't get a picture of what we counted, but those are actually a little bit slightly larger than what we counted. And we counted anywhere between 100 pollen grains to one petri dish had 800 pollen grains. So we counted all those individually. Our data analysis that we did, we used ANOVA and regression. residuals were calculated, and as we learned in class, you measure vertically in the Y space how far each data point is from the line. So there's a picture there showing the red line and then the data points, and the residuals are how far away those data points are from the red line, and below the line is negative and above the line is positive.
So first, we wanted to see if, in fact, there was a difference in the leg lengths between the two types of insect. And here, there is no difference whatsoever. The F value is minuscule, and they're right. The means are together. These and within each other's 95% confidence interval. However, this could have been an artifact of the effects of the body size on leg length. Makes sense. Longer legs correspond with a larger body. Same thing with humans. So we plotted out a regression, thorax length versus femur length, and there was in fact a positive correlation. So then we took the residual leg lengths instead. Notice that a lot of the butterflies that are in red are here underneath the line, and there are these two outlying moths up here, which is why when ANOVAing the difference in the residual leg lengths, we do indeed get a statistically significant difference. Surprisingly, it was the butterflies, though, that had the shorter lengths. Next, ANOVA of the different pollen loads. Here we have the butterflies having significantly more pollen. And finally, a regression to see if there is in fact a relationship between the pollen load and leg length. So residual leg length over here, pollen load, and there is a negative correlation. Insects with longer legs have less pollen. Again, you can see these two outlying moths over here and all those butterflies over here on this side of the graph. So how does this relate to our hypotheses? Well, we hypothesized that butterflies would have longer legs and less pollen. Butterflies had shorter legs and more pollen. So that was backwards. But the other hypothesis that there would in fact be a negative correlation between leg length and pollen load was supported by our data. So we don't know exactly what causes this correlation per se. All we have are numbers. But what we think, and this would have to be confirmed by future study, is that, again, longer legs, you're farther up, less pollen. Shorter legs, closer down, you're all in there in the pollen. You're covered in the stuff.
So for future experiments, we would compare this to bees, since we know the alarming death rate of bees. And improvements is we have small sample size. We only have 8 moths, which is pretty small. But it was kind of cold. We're getting busy with athletics and sports, so it got kind of hard to find time to get it. But an improvement would definitely be find a warmer time, probably in the summer. Okay, so our first hypothesis was incorrect. It didn't flip our results, but it flipped what we thought the results were going to be. We thought that, like Isaac said, we thought that butterflies were going to have longer legs, more pollen. The significance of the study is, with bees dying, moths and butterflies are alternatives for pollinators, and there's no other known studies, to our knowledge, about comparing moths and butterflies. We'd like to acknowledge Williamsburg College Biology Department for giving us lab space and giving us tools. Allowing us to use their campus to catch butterflies and storing some flowers.
Don't tell them we did that.
Dr. Kowinski for his microscope, that really helped, and Professor Nickel and Dr. Kowinski for the knowledge and help on this report.
Any questions?
So why did you initially assume that butterflies were longer? Because just when we were looking at butterflies, just either on picture, just on Google Images, they always seemed higher up on the flower than moths. Just that was kind of the main focus that I had. I don't know.
Yeah, pretty much. It's just the visual aspect of it. Like when you think of what a butterfly looks like, it's sort of like this tall thing with like the wings up there and all that. And then when you think of a moth, moth, it's like low to the ground, kind of, when it's landed at least. So it's really just kind of connotation and what it looks like, jumping to conclusions.
Yes, you, the strangely haired man in the back.
Are there any other biological reasons that could explain why your results besides just
Well, actually, it could be that the insects with longer legs have larger bodies. Well, no, that was stupid. Forget what I said. Yeah, well, the insects with longer legs have larger bodies, and so also it could be that that's what causes them to have more pollen.
Yes.
Yeah, how heavy is pollen to be able to contribute to the weight of the butterfly?
Say that again?
The weight?
How heavy is pollen compared to the weight of the
To
butterfly?
be able to contribute to the total weight of the butterfly.
Yeah.
We don't know exactly. It's less about like the weight of the individual pollen and more just like collectively it weighs, and it could be enough to sort of cause a problem just because the stuff builds up and sticks to you. So it's
So is it just that, like, because they're on the flower, like, sticks to them, or is there, like picking up pollen for a reason? Well,
Yeah,
like, it's like, we had one, literature that I read that was talking about how pollination is mostly on accident. They're there for the nectar, they're there to eat food, and so the pollen ends up getting stuck to the butterfly or moth just on accident, kind of the flower thinking, oh, if I provide nectar, then some of my pollen can get on the butterfly and they can transfer somewhere else. So it's just kind of like in that first slide when we talked about mutualism, the pollinator gets nectar and food and the flower gets pollination. So it's just kind of, we read some articles on how pollination is on accident most of the time.
You were talking about things you could do, like if you were to do the experiment again, you said something about comparing the results to bees. But if that data has already been compiled, like you said that bees and moths and bees and butterflies and stuff have already been analyzed, so what would be the point of?
But we were just saying how that, because bees are dying, just how, I don't think we ever said comparing it
They've been analyzed
specifically.
individually, but
Yeah.
not together.
So they've analyzed bees and they've analyzed like moths individually, butterflies individually, not ever anything together.
and it's sort of about like the application of it. Like the data, yeah, we got that, but like, does that mean that we can kind of help relying on them if we're losing all the bees? Like,
What might be problematic about, sorry,
Well,
So sorry.
Must be all the pollen.
must be, problematic about comparing, like if you were to continue with your study and you use similar methods, but instead of comparing butterflies and moths, I assume you're talking about comparing butterflies to bees. What could be a problem that you might face as you?
Well, if we did, we have to kill the bees. Definitely a bad idea. Knowing how they are right now.
Also, they have slightly different physiology, so I guess the leg to body calculations would be a little wonkier, but
Yeah.
with some diligent thought, it can still be done.
What else is different?
I think those pollen sacs.
Yeah, they have pollen sacs that are.
But we read one of the procedures for measuring the pollen on bees was taking off the pollen sacs because they use those for their own selfish
they do it more on
use.
purpose.
Yeah, it's more intentional. Those bitey little, wonderful and endangered species.
So we're circling a question that that Asa first brought up, which was, when you think about bees because you guys brought up the whole bee thing. When you think about bees versus butterflies, is a moth more like me going to the beach and picking up some pebbles and putting them in my pocket, or me going to the hardware store and carrying around cinder blocks in terms of load? Like, how much pollen is there on a butterfly? Is it enough that it is adding a significant amount of weight that it really is a huge cost to them? Because they're basically, presumably, incurring this cost to get access to the nectar. Is it a pebble in the pocket sort of cost, or is it a carrying around a cinder block sort of cost? Is that clear?
Well, I'm not sure, and that's could be food for future study. But again, all we have is a correlation. We don't have any confirmation of actual selection.
It isn't reliant upon your data. Just what you've read the literature about moths and butterflies and bees. What's your impression?
I guess for impression, I'd say probably more like pebbles maybe.
For who?
For the butterflies.
And for bees?
Yeah, I guess
Certainly,
more.
because they actually intentionally grab buckets
Right.
and stuff.
Yeah, when I think about the pollen baskets, those things are big. Like, I can see a bee flying by and tell you whether that thing is coming back from a flower patch or going to a flower patch.
Right.
Because I can see the pollen basket, it's full of pollen.
Which would mean they would
In
have,
flight.
which would mean they may have opposing selective pressures where the bees would like avoid pollen, even if it's not such a strong selective pressure, it's just pebbles, but bees intentionally want to get into it so they can actually grab the stuff into the basket.
Right.
I'm good. Oh, I need to see to this.